Welcome to our program, Astronomy for Everyone. This month's program is about perspectives in astronomy. Now, Webster defines perspective as the science of drawing or painting so that the objects represented have an apparent depth and distance. To look at this in terms of astronomy rather than a beautiful painting, we have with us here in the studio one of our own Astronomy for Everyone team members, David Baranski. David, welcome to this side of the camera.
Thank you very much.
Now, we're going to talk about this perspective things in terms of the moon, what we see here with our telescopes versus what the Apollo astronauts would have seen being up close and personal.
Right. I've only been with the club for a few years, and I've had my telescope about the same time. And the telescope that I have is a Meade Lightbridge 16-inch mirror, and it's the largest one that I've had. So with this particular telescope, looking at the moon, something very close, I can see a lot of detail in craters and mountains. So I started thinking about, what did the Apollo astronauts see on their way to the moon? How far did they get along there before their view was somewhat similar to mine? How far across that distance am I making it with a telescope? So
that's the topic for our talk, and hopefully
yes.
we can let our viewers in on just what that would have looked like. Now, how would the perspective have differed? Just because of the distance, we're making that up with the telescope?
Well, with the telescope, you've got a certain amount of magnification, and you need to know your focal length of the telescope, and you need to know the focal length of your eyepieces.
And that is where magnification comes in.
Right. And with my particular telescope using particular eyepieces, I can get 73 magnification, or with a Barlow, I can get up to like about 143.
Now, the Barlow is an enhancer for magnification.
Correct. My particular one is like a 2 times Barlow.
So whatever it would be with the eyepiece alone, it would double that with the Barlow.
Correct.
Okay.
Correct. And so, and not only doing that, but also figuring out, well, okay, what is the distance that I'm seeing across there? There's another equation that you can do that divides the distance divided by magnification. So if you were to divide, like my particular telescope and the distance of the moon, it's somewhat equivalent to being 3,000 miles away. With a Barlow, maybe about 1,000 miles away.
Okay. And I see we have some of those equations up here on the screen right now
right.
to give folks the sense of what you're talking about.
Right. So like say with a 2-inch eyepiece that I have, it's about 3,000 miles, and with a Barlow, 1,400. Now just to even give another frame of reference here, the Apollo command module, when it was parked in lunar orbit, that was 70 miles, roughly about 70 miles away from the moon. So thinking about how far I'm going across with a telescope, I'm overcoming a lot of distance there. And I didn't even have to get into a rocket to do it.
Exactly. You just had to buy yourself a real nice Lightbridge telescope.
That's right. That's right. And the picture that we have here kind of shows that the Apollo command module, of course, being parked above the moon, and with my particular telescope, the different magnifications that I can get. So again, with my Barlow, with a Barlow in there, I'm pretty close to being near the moon.
I can see, yeah, right there with the lower number, the 146 is twice the upper number there at 73. So you've just about halved the distance there.
Correct.
If I can see the screen properly there. There we go. So at 70 miles, though, do you think you could crank your scope up enough to get it to that 70-mile distance? Or is that hoping for too much, you think?
Too much for my particular telescope. So
okay, we need a little bit more aperture.
More aperture, more different eyepieces, bigger eyepieces. So
okay. All right. So we've taken a look at the image showing the various distances. Now, scale comes into it as well. As you look at the moon, there are a plethora of craters of varying sizes. to kind of equate those from the scope to like actual distances here on Earth. Can you?
Right, there's many craters to look at, but again, when you're looking at the different craters, you know, you can go to some sort of application. It'll tell you what the diameter is, but you know, just looking at it, you really can't tell how big or how small it is until you know kind of compare it to something well known to your particular area.
Well, this
So-
image that we just had right here, if we could go back to that for just a second. Which
So-
crater is this?
So for Tycho, I believe this is Tycho. So for Tycho crater, it's roughly about 53 miles. 53 miles would be the distance from Lake St. Clair at the beach there, going all the way through part of Macomb, part of Oakland County, out to Island Lake Park, where we have our outreach programs.
So yeah, I don't know if they can make out those little yellow hashtags on there or not, but that's roughly the distance from the Metro Park there on
Right.
Lake St. Clair all the way to Island Lake, which is right next to Kensington
Yeah.
Metro Park.
And you figure that's about maybe an hour, depending how fast you drive, it might be an hour, hour and a half drive. So looking across the crater, you know, okay, I'm not going to see footprints, but I am seeing a lot of detail.
Oh, sure, yeah. And we're not going to see the flag either.
You're not going to see a flag either.
Oh, yeah. But that does, I think, give some perspective for folks when they see, oh, it's 53 miles.
Yeah.
Well, okay, you understand what that number is, but to say from Lake St. Clair Metro Park all the way to Kensington,
Yep.
and then that's something I think most folks in the metro area here can get a grasp of and say,
Right.
wow, that's pretty big.
Yes, yes. And the next slide that I have is with Copernicus, crater Copernicus, which is a little bit larger. It's about 57 miles across. And again, if you use the same type of scenario, if you drove north from downtown Detroit, and of course you're going through Wayne, Macomb, and somewhat into Genesee County before you're reaching 57 miles. So again, you know, looking at that crater by itself through a telescope, you really can't put any frame of reference to it. But if you think about how far I got to drive just to get that distance, you know, you're going through 3 counties. So it's a huge crater.
Yeah, I was just going to say, driving that type of a distance from downtown to, you know, past Pontiac, I
Yes.
think it is. You know, almost, I think, maybe even to Grand Blanc.
Yes, Grand Blanc, yes.
It really, for me anyway, it really goes, wow. And that's just a crater. Now, it's one of the larger ones on the moon, of course.
Yes.
But still, if you look at it in terms of the bigger picture, if you were to back off the magnification to see that crater in a larger sense on the surface of the moon, it really brings it home.
Yes, it does.
Now, anything that you'd want to mention, that something that you've learned in doing this? Or?
The thing that I've kind of learned is that, you know, well, when I grew up like in the 60s, I mean, just about everybody wanted to be an astronaut, you know, get strapped to a rocket. It's not, you don't really have to do anything like that. I mean, a telescope will get you pretty far. There's a lot of things up in the sky that you can see with a telescope of that size. Not only can you see details on the moon, but you can see things that are 8,000 light years away with great detail.
That's the wonderful thing about a telescope. I would like to thank David for being on our show today to give us an insight into perspective. If you have any questions, you can always send us an email, of course. Our email address can be seen down there at the bottom of the screen. We would really like to hear from you. And coming up next is our term of the month with Stephen Whitty. And after that, I'll be back with our next guest to talk about the Ford Amateur Astronomy Club's Beginners Nights.
Thanks, Don. The term of the month for March 2014 is laser. The National Science Foundation had a survey. They just published the results of a survey, and one of the questions on it was true or false. Lasers work by focusing sound. That was the question. So, it's false. If you got it wrong, don't worry about it too much. I'll get to that in a second. If you got it right, congratulations. But if you got it wrong, only 47% of Americans got this question right. In fact, the United States was tied with the European Union for having the most correct, people of the public be right on this question, 47%. So no nation on Earth have even half of the population getting this question right. And I thought this was disturbing because you can go to the dollar store and you can pick up a little laser pointer. We used to use them for presentations. A lot of people use them as cat toys. And when you shine the laser, it doesn't make any sound. So all it does is it shows light. In fact, some of these cat toys, they don't even make a noise when you press the button. So I thought maybe Hollywood is to blame, because when you've got Star Trek or Star Wars, whenever a beam of light, it looks like a laser anyway, goes by, there's always an accompanying sound effect. So maybe I thought Hollywood was to blame, and maybe they are, who knows. But there's another thing. The laser is actually a fairly new invention. It was invented in 1957, and there are plenty of people who are older than the laser. But actually the laser was not the invention exactly. We already knew about something called masers, which are microwave lasers. So a laser is light amplification by stimulated emission, and a maser is the same thing but microwave instead of light. So, and these masers are sort of powered by a nearby star. There's a gas cloud, some light goes through the gas cloud, and it gets amplified in the same way that lasers work. So the term of the month for March 2014 is laser. Next up is our list of upcoming events.
Thanks, Stephen. Welcome back to the show. In this part, we're going to be talking with another one of the Ford Club members about our beginners' nights. It's something that the club's been doing for, gosh, Gordon, I don't even know how long we've been doing it.
I've been in the club for 12, 13 years, and they were going when I joined, so it probably goes back to the beginning. 1992 maybe, I don't know.
Something like that.
Yeah.
Anyway, I think it's important that we want to bring this event, this ongoing event actually, it's more than one event, to the general public for folks who, maybe you've got a telescope for Christmas and, they don't know what end to look through, or they inherited a scope from Uncle Louie and they wonder what to do next. So, Gordon, what are beginners' nights?
Well, I think you gave a pretty good summary right up front. It's an event that we put on monthly during the spring months where we invite people who have gotten new scopes, who've had one sitting in their closet for gathering dust for years, couldn't quite figure out how to get the thing to work, and they were looking for some assistance. So we invite them to come join us on typically the first Saturday, the Saturday after the first quarter moon of each month, and starting in April. To come on out, and we'll try and give them some help.
Now, who can attend beginners' nights?
It's open to anybody who's really got a telescope. The other purpose of the event is also a social event for our club members. So it's kind of the one time a month where we get together to go out and look at the heavens ourselves. So there's typically going to be 30, 40 of our club members out there with telescopes. So you not only get to hopefully see get some help with your scope. But if you're thinking about purchasing a scope, would really recommend you come on out and walk around the park and look at others people's scopes and start getting a feel for what you may want to buy.
Talk to the owners of that
Right.
particular piece of equipment.
Before you go spend good money on a telescope and said, "Oh, I made the big mistake," go try some out. And my experience has been, we astronomers just love to show off our equipment. So we'll talk your ears off if you give us a chance.
Yes, we do. Yes, we do. Now, the type of help available would be how to set the scope up.
Yeah, set it up. If it's an equatorial scope, and we're getting some terminology here, but if it's got to be polar aligned, if it's shaking and it needs this thing called collimation, we can start helping with. So there's some things that a beginner needs to learn how to do to be able to, before he starts pointing it up in the sky. So that's what the purpose is.
Things that maybe the instruction manuals don't
Yeah, they're typically pretty sad. So
cover. Yeah. Well, plus it gives these individuals, newbies, if you will, a chance to talk with folks who've been at it for a
Exactly.
while, to the benefit of our trial and error.
Yes, and we've had lots of trials and errors.
That's, I guess, how we learn best.
That's correct.
Now, it's also important for folks to know what beginner's night is not.
Yeah, it is not a public star party. One I'm sure you bring up on the show here is the Astronomy at the Beach in September, where there'll be 100 people out there with telescopes, where we encourage just people to bring out their families and their kids and just look at the sky. That's really not the purpose of this, although we are going to do some obviously looking at the sky, but it's really to help get telescopes set up, not so much to become a public outreach.
So we would prefer just folks who have an interest in
Yes.
in equipment or learning about
That's right.
equipment to make a purchase.
We're not looking for a school bus full of middle school kids to come on out, and that's not what this is about. It's not a star party.
We, in that sense, with the busload of school kids, we wouldn't mind coming out to their school
That's right.
to do
Yes.
a little star party for them. But the beginners' nights is not
Yeah,
the
that's
vehicle
that's correct.
to do that. Now, important thing, as I mentioned earlier in our discussion here, when they're held.
Okay, first one this year is April 5th, and this one will be held at Lake Erie Metro Park. We're doing two at Lake Erie each year now. So the first
Okay.
one will be at Lake Erie, and that one's going to have a little bit of different complexion, is that we will actually be doing a little bit of an astronomy presentation in the classroom before it gets dark. So there we'll be doing some what's up in the heavens, talk about equipment a little bit.
That'll be inside the Marshlands
Yes,
Museum.
Marshland Museum's at Lake Erie Metro Park.
And will the observing after that be at the museum, or will
Yes,
we move
yes.
it
So they'll turn the lights out in the parking lot, and we'll do the observing right from the parking lot.
just like we do for ice days?
Yes, exactly.
Okay.
The next one will be May 3rd. Now we move back out to Island Lake Recreation Area at Spring Mills Ponds. That's on the opposite side of I-96 from Kensington. I think most people know where Kensington is, may not know where Island Lake is.
Right, you can get off at the Kensington Road
Road
exit,
exit.
and instead of going straight across, you make the right, and then just south of Grand
Exactly,
River and
right.
the freeway.
And it's
Quarter
about-
mile on the left is the entrance.
Right,
to the
entrance. And then you work your way back to Spring Mills Pond, and we're just beyond the pavilion is where we set up. The next one will be June 7th, then July 5th, then August 2nd,
park. Okay.
and then we skip September because that's when the Astronomy at the Beach event is, and so we don't want to try and go head to head with that.
Exactly.
And then we end the year on October 4th back at Lake Erie Metro Park with a similar thing as we did in April.
All right. So then we have a total of, if I'm doing the math, 6
Yeah.
different events
Yeah, I guess enough.
that people can attend, in addition to Astronomy at the Beach, which is a public star party. But if you're looking to get help with equipment, if you'd like some help in figuring out what type of equipment that you would like to buy, certainly Beginner's Night is the place for you.
I guess if I could throw one more piece in here.
Sure,
quick. What I'd recommend, if somebody does have a scope, if you could send us an email or something ahead of time and say, I've got a Meade LX200 and we need some help with it. This way we can try and find a club member who's got a similar piece of equipment that can better able to give you some assistance.
And what would be that email to contact the club?
Well, you could go to president at FordAstronomyClub.com. We'll get to our current president, Tim Campbell, and
Okay.
we can then start working from there.
All right. Well, we'll get that email on the website so folks can have that as well. And of course, you can always visit the regular club website, FordAstronomyClub.com, and just follow the links for current events, I think is where they can find it, if it isn't right there on the home page. Well, I would really like to thank Gordon. Thanks again
Yep.
for being on the
Thanks for
show
having me.
to talk to folks about beginners' nights. And if you have any questions, you can also visit the Astronomy For Everyone website. We'll try to have some information there, but another good place would be the FordAstronomyClub.com that I mentioned a little bit earlier. Before we head off to What's Up in the Night Sky with Steve Whitty, I did want to take a couple of minutes to remind you about the 11th Annual Astronomy Show and Swap Meet, sponsored by the Ford Amateur Astronomy Club. It's coming up on Saturday, March 15th, the 15th of this month, at Holy Cross Lutheran Church. It'll be inside their gymnasium. Now, the church is located at 30,650 6 Mile Road in Livonia. That's between Middle Belt and Merriman. It's on the north side of the street as you're heading west. Again, it'll be from 9 a.m. to 3 p.m. There will be astronomy presentations of various topics and also planetarium lectures in the Star Lab portable planetarium that has been loaned to us courtesy of the folks at the Michigan Science Center. To get information about the admission cost and also to find a map if you're not familiar with the area, you can again go to FordAstronomyClub.com. We'll have that email on the scroll so that you can pick that up as well. This is for families, mom and dad, the kids, scouts, Boy Scouts, Girl Scouts. It's a great place if you're looking to buy some equipment. There's new and used. Again, we'll have those astronomy presentations and the planetarium lectures there. The times will be posted when you get to the swap. So we hope you can make it out. It'll be there, rain or shine, snow or whatever the weather's going to throw at us this year. So please put it on your calendar. So if you're seeing this show before March 15th, please head on over to the show and swap there at the Holy Cross Lutheran Church Gymnasium. Want to thank you for watching this part of the show. Coming up next, as always, at the end of the program, will be Stephen Whitty with What's Up in the Night Sky. Stephen.
Thanks, Don. This is What's Up for the Night Sky for March 2014. We'll start with the moons. Now, February did not have a new moon at all, so March has two, one on the 1st and one on the 30th. It's not on the 31st. March is a big enough month that it can actually have two of the same phase of the moon and even have a day to spare. So March starts off with a new moon, and that's a great time to be looking for stuff in the darker sky because the moon isn't there to wash it out. On the 8th, we have the first quarter moon, and that's when the moon is visible in the evening and into the night. On the 16th, we have the full moon, and so the moon is up all night long. On the 30th, we have, on the 23rd, we have the third quarter, erroneously here marked as the 30th. And then finally, at the end of the month, we have the 30th. We have the new moon again. Sunrise this month is around 7 all month long. And it sets starting at the month around 7:30, and by the end of the month, it's around 8 o'clock. So the days are getting longer. We're getting farther from the winter solstice in December, and we're getting closer to the summer solstice in June. Jupiter sets at around 3 a.m., so it is up until 3 a.m. So this picture is from the 16th of March, so this is the middle of the month. These are all middle of the month pictures. at 9 p.m. So at 9 p.m. Jupiter is quite high in the sky. It's like 60 or 70 degrees up in the sky. In the northern hemisphere. It's pretty easy to spot, and it's near the knees, I guess, of the twins, the Gemini twins. So the feet are sort of below Jupiter there, and just to the right, as you're looking at the Gemini twins, there's an open cluster called M35, and there are several open clusters right here. This is a nice little cluster segment because the Milky Way comes right through here. So M35 is probably the easiest to find right there by the foot. Binoculars or larger instruments are great for these things. They're great telescope objects as well. M37 is next, and then M36 is further into Auriga, and it's not shown here, but a little bit beyond that is M38. These are all open clusters. They're wonderful. Take a look at them if you get a chance. Mars rises at 9 p.m., so you're looking in the east. It's in Virgo, and on the 16th, so it rises at 9, so we're looking at 11, give it a little bit of time to get above the horizon. On the 16th, we have the full moon to sort of accompany Mars. Saturn doesn't rise until 11, so here we are at 1 in the morning on the 17th, and you can actually see that Mars is in this image as well, but Saturn is in Libra below Mars, and so you get Saturn and Mars sort of together, but that's 1 in the morning. Now you can also see Vesta to the upper left of Mars in that image, and Vesta is one of the two brighter asteroids, Vesta and Ceres being the brightest. And the Dawn mission recently visited and orbited Vesta and is on its way to Ceres. This summer, July 1st, Vesta and Ceres are really close to each other. You can see them both in a telescope view, and they're good in binoculars as well. They're quite bright. They can be seen naked eye if you are at a dark sky site and know exactly where to look. Finally, Venus rises at 4:30 in the morning. So here it is at 6 a.m., that's what I recommend, in the constellation Capricornus. So this is also on the 17th. So this is Venus. This is what's up in the night sky for March 2014. Keep looking up. It's the best free show. It's above your head every single night.